welcome back to the Michigan Business Beat, brought to you on the Michigan Business Network. I am Chris Holman, and we are broadcasting from our downtown studios for a change. By golly, how about that? I actually still have the key to the front door. It's pretty cool. Frank DeLuca joins us right now. He's the Director of Application Sales Engineering for CoreTechnologies in Southfield, Michigan. Frank, thanks for taking the time to join us. Tell us a little bit about CoreTechnologies.
Thanks for having me.
What you got?
So go ahead. Yeah, so CoreTechnologie, we actually started over 20 years ago. The first solution we actually developed was our 3D kernel IO, so our CAD API library. So we developed our own CAD API library to be able to read in native CAD files and optimize and translate them for downstream applications. So some companies are trying to migrate from one solution to another, going from CATIA to NX. So that was a huge need in the industry 20 years ago. So our developers and our team from Germany and France actually developed the software to automate those processes and utilize our kernel for that solution as well. So, since we understood CAD geometry so well, we decided to get into the additive manufacturing space. So since we knew how to read in native CAD, and we do this from the binary code itself, we knew how to manipulate CAD. We're not a design package, but, we can take in any native CAD file, read in the fully featured parametric model, see all the, the features, the designs, so you can see the PMI, so you understand the design intent as you start going into the additive manufacturing processes. So it's really cool to see, what our development team has kind of come up with.
Well, from Genesis to date, I mean, there's been a lot of evolution, obviously.
Oh, yeah. Yes. Yep.
All right. So listen, we ran into you at Automation Alley's recent Integrate. Tell us a little bit about your relationship with them.
With Integrate? Yeah, this was actually our first year attending that. It was a great show. I really like the environment. It's not a huge show. It's not like an IMTS where you have to walk 10 miles just to go talk to different representatives and things like that. So it was a great show, really small, niche, really wanted to show and display, what we have to offer for the industry. Not many people really know who CoreTechnologie is. We have less than 100 people worldwide, but, over half of our team is on our development center in Lyon, France. So it's really cool to be a part of these shows and, seeing all the industry and how it's trending, and innovating. Everything's always changing. It's really cool to learn about what other companies are doing.
Well, I'll tell you what else. It put you in touch with us, which we're grateful for, because you have a fascinating company.
Yeah, so I definitely appreciate this opportunity.
So listen, tell us a little bit about DFM, which is really designed for manufacturing.
Yeah, so since we have the ability to read in native CAD, and understand from the binary code, now we can start doing different analysis. Whether you want to do a wall thickness checker to make sure you don't have any thin walls, because you're going to a multi-jet fusion. So if you have a wall underneath a 0.5 millimeter, it could essentially now collapse and not be able to utilize for downstream. As well as internal backlash detection. So if you have a small hole that's smaller than 0.8 millimeters, when you're using like an MJF machine, that hole is going to be fused together, so you're not going to be able to see that hole anymore since it's underneath 0.8 millimeters. So you're doing different analysis to ensure that you're not going to have problematic areas downstream. And so the ultimate goal is to remove and reduce the post-processing efforts in additive manufacturing. And since we have a solution to pre-process to optimize that solution to try to reduce post-processing efforts, using the DFM for that helps to understand, which application you're using and then what type of problematic areas you might have. I talked about backlash detection. It's also detecting, close spaces that are in proximity to each other. So if you have an angle, greater than 60 degrees, that angle down at the bottom might actually get fused together, and it might look really rough and not as clean as you would like it to. So that helps, understanding the process and understanding the design as it goes into additive manufacturing. Make sure you're not going to have any problematic areas for post-processing efforts.
So tell me a little bit about Lattice functions and the options that they have for minimizing material usage.
Yeah, so it's great, with the Lattice options that we have, we have 18 different structures that you can utilize, both 2D and 3D. And then what's really cool is we even have what's called a variable lattice option. So we can actually control the density in a linear direction as it moves up the model. So if you have some high stress areas, you can make sure that part of the lattice structure is more dense than another part you're just trying to reduce the material and reduce the weight of the model. So, we can optimize essentially the lattice structure generation based on what type of solution you're going to be utilizing. Like if you want to be using a resin printer, we can have a specific lattice module as well as a plug to make sure we can get the resin out of those modules and things like that too.
So your company has cut tools. Tell me a little bit about that.
Yeah, so I mean it's huge for especially for the aerospace industry. Currently today, a lot of the engineers they're actually designing these huge parts and massive components. But the problem is, you have a huge part, you can't print it. So what they're doing is they're actually designing each part in different sections. So when you have to put in a lap joint, you have to manually design that lap joint into the model, which now takes, instead of 8 to 16 hours, you're talking about 40 hours to start to separate these parts because of all the design and all the control you have with it. So with our cut tool, now you can design that part as one solid piece and then use the lap joints or use the pins to now separate that part and have a piece that can still connect to it, and even have a tolerance in there that you can put for adhesions and things like that. So it's a really cool feature that saves a ton of time for downstream.
So listen, we got literally 30 seconds left. Techniques of industry 4.0 that allow you to access thousands of predefined templates.
Yeah, so the access to over 5,000 different textures. Actually, I think it's close to almost 15,000 different textures options. And what's really cool is that it's a standard template option that you have that now you can optimize for your application. So whether you want to, so if you would choose like a stitching option that you have for your car or automobile application, now you can control single stitching, double stitching, you can control the height of the stitching, you can control the color of the stitching. So there's a lot of different cool options that you have with the texturing. And you can make sure you even wrap it around cylinders very perfectly. You don't have elongated textures. You don't have it's really optimized for the end goal to make sure it's very robust and very clean looking, especially in the automotive industry. So it's really cool what we have with that solution. Very quick.
You guys are the perfect example of 4.0. Trust me. Frank DeLuca, Director, Application Sales Engineering at CoreTechnologies in Southfield, Michigan. Frank, thanks for joining us. Keep up the good work, buddy.
Thank you. Appreciate it.
You've been watching the Michigan Business Beat on the Michigan Business Network. I'm Chris Holman. We'll be back in a minute with more.